Galaxies that shouldn't exist, black holes growing impossibly fast, water vapor on distant worlds, signs of potential life beyond Earth. All these discoveries were made by the James Webb Space Telescope. Sounds interesting? Then watch this video to the end.
In September 2022, astronomers were staring at their computer screens in complete disbelief. Webb had just discovered galaxy JADES GSZ 14O, a massive, bright galaxy that existed when the universe was only 290 million years old. This wasn't supposed to be possible. According to all our models, galaxies this large and luminous should take billions of years to form, not a few hundred million. But there it was, shining brightly in Webb's infrared vision, completely breaking our understanding of how the universe evolved. This single discovery forced scientists to rewrite textbooks about cosmic evolution. You might be wondering, how did this telescope manage to see something that far back in time and revolutionize astronomy? Well, it's the perfect time to meet the cosmic detective responsible for these mind-blowing discoveries. The James Webb Space Telescope isn't just another space camera, it's humanity's most ambitious attempt to understand our origins. Named after James Edwin Webb, the NASA administrator who led the Apollo program, this $10 billion marvel represents 20 years of cutting-edge engineering. Webb's primary mirror is 6.5 meters wide, nearly 3 times larger than Hubble's. But size isn't everything. Webb sees in infrared light, which means it can peer through cosmic dust clouds that have hidden secrets for billions of years. It's like having superhuman X-ray vision that can see through the universe's greatest mysteries. The telescope sits 1.5 million kilometers from Earth at Lagrange Point 2, where it has an unobstructed view of the cosmos. Its massive sun shield, the size of a tennis court, keeps its instruments at -230 degrees Celsius, making it sensitive enough to detect the heat signature of a bumblebee on the moon. This incredible sensitivity is what allows Webb to capture light that has been traveling for over 13 billion years.
Webb has revolutionized the search for life by giving us the ability to analyze alien atmospheres in unprecedented detail. In 2023, Webb made history by detecting water vapor, clouds, and even weather patterns on exoplanet K2-18b, a world located in its star's habitable zone. But the real breakthrough came when Webb detected dimethyl sulfide, or DMS, in K2-18b's atmosphere, a molecule that on Earth is only produced by living organisms. While scientists are being cautious about claiming this as proof of life, it's the strongest potential biosignature ever detected on another world. Webb has also studied the 7 Earth-sized planets in the TRAPPIST-1 system, revealing that several of these worlds might have thick atmospheres and possibly liquid water. The telescope's infrared vision can detect specific molecules like oxygen, methane, and carbon dioxide, the chemical fingerprints that could reveal living worlds. Perhaps most excitingly, Webb discovered that rocky planets around red dwarf stars can retain substantial atmospheres, dramatically expanding the number of potentially habitable worlds in our galaxy. Each observation brings us closer to answering the ultimate question: are we alone in the universe?
But Webb's most terrifying discovery involves supermassive black holes that grew impossibly fast in the early universe. In 2024, Webb detected active supermassive black holes in galaxies that existed just 400 to 800 million years after the Big Bang, including Sears 1019, a black hole with 9 million solar masses. Here's what's absolutely mind-blowing. These black holes are nearly as massive as the one at the center of our Milky Way, but they existed when the universe was just a tiny fraction of its current age. According to physics, black holes should grow by slowly consuming matter over billions of years. These monsters somehow bypassed the speed limit. Webb also discovered that many of these early supermassive black holes are actively feeding, creating quasars so bright they outshine their entire host galaxies. These cosmic lighthouses are visible across billions of light years, powered by matter spiraling into black holes at millions of degrees. Perhaps most shocking of all, Webb found evidence that these black holes might have formed before their host galaxies, not after. This completely flips our understanding of cosmic evolution. Instead of galaxies forming first and then growing central black holes, it appears that massive black holes formed first and then built galaxies around themselves.
Webb's first major shock came when it discovered what astronomers now call universe breaker galaxies. These 6 massive galaxies existed when the universe was between 500 and 700 million years old, and they're so large and mature that they challenge our fundamental understanding of cosmic evolution. The most stunning example is galaxy Maisie, observed when the universe was only 390 million years old. This galaxy is already massive and actively forming stars at an incredible rate. It's like finding a fully grown adult in a nursery. It simply shouldn't exist according to our models of how galaxies grow. What makes these discoveries even more shocking is that these ancient galaxies appear to contain as many stars as the Milky Way, despite forming in a universe that was supposedly too young and chaotic for such organized structures. Webb revealed that the early universe was far more efficient at building massive galaxies than we ever imagined. Some of these galaxies are so bright and massive that they're forcing astronomers to reconsider the rate at which dark matter formed the cosmic web. If galaxies could grow this large this quickly, it suggests that the universe's structure formation happened much faster than our current models predict. Webb has also transformed our understanding of how stars and planets are born by peering inside stellar nurseries that were previously hidden from view. The telescope's infrared vision cuts through cosmic dust clouds, revealing the violent and beautiful process of star formation. In the Carina Nebula, Webb captured images of newborn stars blasting away their birth cocoons with powerful stellar winds. These baby stars are so hot and energetic that they're sculpting the nebula around them, creating cosmic artwork on an unimaginable scale. You're witnessing the universe's creative process in real time. Webb also discovered brown dwarfs, failed stars that never quite ignited nuclear fusion, forming planetary disks around themselves. This suggests that planet formation might be far more common than we thought, occurring even around objects that barely qualify as stars. The telescope revealed that star formation in the early universe was much more chaotic and violent than today. Ancient stellar nurseries were feeding frenzies, where massive stars formed and died in just a few million years, seeding space with heavy elements that would eventually become the building blocks for rocky planets and life. Perhaps most intriguingly, Webb found evidence of planet formation happening around stars of all sizes and types, suggesting that planetary systems like ours might be incredibly common throughout the universe.
The James Webb Space Telescope has fundamentally changed how we see the universe. From impossible early galaxies to potential signs of life, from monster black holes to stellar nurseries, Webb is answering questions we've wondered about for centuries while revealing new mysteries we never knew existed. And the most incredible part? We're only seeing the beginning of what this cosmic time machine can teach us. Which Webb discovery shocked you the most? Share your thoughts in the comments below. And if you want to explore more mind-blowing space discoveries, hit that subscribe button and turn on notifications. The universe is revealing its secrets, and together we'll witness them all.